Okay, another question that a few people had issues with. This is from 3L example 1, okay, which is quadratic models. Okay, so let's have a go. So in this example we have a piece of wire that's 68 centimeters long in length and it's bent into a rectangle. Let W centimeters be the width of the rectangle. Okay, so let's draw the above rectangle, labeling all information. So we have a rectangle, okay, it has a width W, okay, and down here we're going to express the length as L, so we can put that in, okay, width and length, okay, and we're also told a piece of wire was 68 centimeters, so our perimeter is equal to 68 centimeters. Nice and easy. Okay, write an expression for the length of the rectangle L in terms of W. So we need L equals something something W. Okay, and because it's length, that means we're going to invoke our perimeter. So perimeter is equal to 2 times the width plus 2 times the length. Okay, so we know our perimeter was 68 equals 2W plus 2L. Okay, we want in terms of W, so we get 2L equals 68 minus 2W, okay, and L equals 68 minus 2W on 2, which is equal to 34 minus W. Okay, now write an expression for the area of the rectangle in terms of W and L. Well, that's pretty easy. That's year 7 area, so we got area equals width times length is equal to WL. Okay, create a quadratic function. So this is where it gets a bit harder. Create a quadratic function by substituting your expression for length into expression for area. So what we're doing is we're taking this, okay, which was equal to L, okay, and we're going to put it in that. Okay, so we get area equals W by, okay, instead of L we're putting this in, 34 minus W, okay, which is equal to negative W squared plus 34L. Okay, so not that hard in the end. Okay, decide on a suitable domain. Okay, and it says note, we can't have negative area or a negative length. And another hint is find the W intercepts. So let's think of this. This is an expression telling us the area of our shape. Oh, that's supposed to be a W. My apologies. That's a W there, 34W. Okay, so we have an area is equal to this expression given a certain width value. Okay, so let's do a quick little sketch as well of this. Okay, so it's a negative W squared, so that means it's a parabola, okay, turned, and what's quite handy is when we think of it in this form, it gives us our intercepts just by inspection. We know one has to be 0, okay, you know, one has to be 0, and the other one, it's a negative W, so that'll be 34. The other one's going to be out here at 34. This is W. This is our area. And because it's negative parabola, we're going to get something like this. Okay. Now, even if we didn't know these 2 points, okay, if we just went with it's a negative W squared, we know it's going to be a parabola this way. So the only possible values, okay, are going to be when the area is positive. So up here, okay. And then if you did have something like this, you would actually cut it off here because we can't have a negative W. Okay, you can't have a negative width for a shape. So this would be our area or our possible domain. So let's find our intercepts. Okay, so area equals negative W. Actually, we'll leave it in compressed form. Okay, so with this, W needs to be equal to 0, or, okay, to make this, sorry, intercepts, we're going to make that equal to 0. 34 minus W, so to make that work is 34. Okay, so on this sketch up here we have 0, 0, and this one is 34, 0. These are 2 intercepts. Okay. Now, another thing we want to check is we don't have a negative length. So let's put in a 0 for a W and check our formula up here. Okay, so length, if we put in a 0W, we get a length of 34. Okay. And then if we put in the maximum, we put in 34 in here. 34 minus 34 gives us a length of 0. Okay, so our possible domain, okay, is between 0 and 34. We can't have 0 because we got 0, it turns into a line, it's no longer a rectangle. We can't have exactly 34 because it'll turn into a line as well. Okay. So let's find the maximum area. As we go by our sketch up here quickly, okay, our area maximum, okay, is at the turning point. Nice thing with the turning point is always halfway between the two intercepts. TP is halfway between intercepts. Okay, so the TPW is equal to 0 plus 34 on 2 is equal to 17. Okay, so our turning point W, we can substitute that into our area, so area is equal to W, what do we have up here? 34 minus W is equal to 17. 34 minus 17 is equal to 34 minus 17, 17, so we get 17 squared, which happens to be 289. Cool. So maximum area formed is when width is 17, okay, turning point width, and if we go back up to here, if we put in 17 in here to find our length, 34 minus 17 is 17. So it just so happens the biggest shape we can make is 17, 17 area wise. Okay. Will give us our maximum area, and that's actually true for any shape. If you have a fixed length perimeter, the way you can generate the greatest area is always to make it a square, always. And now sketch A against W over a suitable domain. I'm going to apologize in advance for my sketching, doing this on a note. Okay, we have that. Okay, and we figured out up here, okay, 0, 0, 34, 0 are our two intercepts, and then our turning point W was at 17, and our area is 289. Okay, so we're going to put in there, we're going to have 0, 0, we're going to go here, we've got 34, 0, put in our turning point at halfway, okay, and that was 17 to 89. So this is our W, this is our area, put in, and this is where I again apologize for my poor graphing. Okay, it doesn't continue past there because we can't have a negative area and we can't have a negative width or length. So that's our suitable domain. And that's that question done.